Hi there, my name is Noel Gorlick and I'm a software engineer at Google. I'm one of the co-founders of Google Earth Engine and I'm joining you today from Zurich, Switzerland. Before we get started, I just want to highlight the Ask a Question feature on this site. The Ask a Question feature is directly below the image of me you're looking at right now. As you watch this, feel free to ask questions by typing them into the field, and we'll leave 15 minutes at the end of the presentation to answer questions. Of course, I'll have some of my own. I'm honored today to introduce you to Liza Goldberg. We here at Google got introduced to Liza in 2017, and she was one of the early adopters of Google Earth Engine. She's taken her experiences and integrated them into what she's going to talk about today. It's been very impressive, the work that she's been able to do with Earth Engine, and we look forward to seeing more from her in the future. Take it away, Liza.
Thank you so much, Noel. Hi, everyone. My name is Liza Goldberg, and I'm a biospheric researcher at NASA Goddard Space Flight Center, and I'm also a freshman at Stanford University this year, joining you from Stanford, California. And today I'm really looking forward to speaking about both my experiences with using satellite imagery to monitor global environmental change, and furthermore, how you can actually use those satellite technologies yourself to help introduce your students to how we can monitor global environmental change from space. So with that, I will take it away with my presentation. So today, again, I'm really excited to speak to you about a program that I started several years ago called Cloud to Classroom. And really the goal here is to bring a bird's eye view from space of a changing planet in terms of all aspects of global environmental change to students and the next generation in general. But to just kind of back up a moment, I would love to share just a minute of my story and where I'm kind of coming from here. So I started my work for NASA when I was 14 years old, and over the last 5 years or so, I've been working to use satellite imagery and Google Earth Engine in particular to monitor global change in coastal and tropical ecosystems around the world. So most of my work involves assessing using satellites how human impacts and different climatic and environmental impacts like erosion and sea level rise are impacting mangrove ecosystems, which are one of Earth's most threatened coastal forests. And more broadly, assessing how we can actually use those data from satellites to inform sustainable development policy in communities and governments from the local to the international scale. So really throughout my time at NASA, I've had the opportunity to use satellite imagery to see the world from a different perspective. But unfortunately, when we look at how these sorts of global scale issues like environmental change and climate change are communicated to the public, all we're really left with is just a series of news headlines like this from the New York Times, or like this one from The Guardian, or like this from the Washington Post. And ultimately, when we put together all of these headlines that we're seeing on a daily, monthly, or yearly basis, we see we have a pretty clear consensus here. We should be alarmed. But why is it that we aren't necessarily alarmed? Why is it that the public around the world sees climate change still as kind of an existential issue, something that we know is happening, but we don't really understand how it's tangibly impacting communities and ecosystems around the world? We're unable to really understand and see with our own eyes how climate change will actually become a threat either now or in future generations. Ultimately, I think a lot of this lies in the fact that we're unable to actually see for ourselves kind of how climate change is already impacting different populations outside of our own homes. But with satellite imagery, we're actually able to kind of bridge that gap and see the world as a whole outside of just our own towns and cities. We're able to see things like deforestation as it occurs across the Amazon, as you can see here in Rondônia in Brazil. Time lapse from 2000 to 1984 to 2016. Or this new example of environmental change as the Great Salt Lake in Utah shrinks due to irrigation and overuse of water throughout the Great Plains region. Or in this example, where we see the shrinking of the Columbia Glacier, which is an iconic glacier in southern Alaska. You can see this time lapse over several decades. And ultimately, using these satellite images, we're able to kind of create a sense of empathy in audiences and help them better understand and see with their own eyes how these different environmental changes are already tangibly having an impact in various parts of the world. But then the question becomes, okay, so we have these satellite images, but how do we actually capture and quantify these changes so we understand the degree to which these different environmental changes are impacting communities and ecosystems? And it turns out that's actually where Google Earth Engine comes in. So I always think of Google Earth Engine as kind of like the back end of Google Earth. It's where we're able to actually access all of those satellite images that you've seen in these time-lapse videos and in the Google Earth platform itself, and actually process all of those satellite images in order to gain insights and, as I mentioned before, quantify with numbers and data the extent of these changes that are occurring in both your community and other communities and ecosystems around the world. So the idea behind Earth Engine is that we're able to access a pretty exhaustive catalog of all sorts of remote sensing, so satellite-based data sets. So things like multispectral data, climate data, land cover data, so looking at things like where cities are and where different land types are, as well as spatial data as well. All of these data are actually stored on Google's servers, and then you're able to access all of these different data sets using a JavaScript-based programming interface that's completely online. And if you're more familiar, or if you have knowledge of Python as well, there are also different ways of accessing these data sets using Python interfaces, which I won't necessarily go into today, but I can give some resources at the end. And the unique part of Earth Engine is that it's all just browser-based. There are no downloads involved, and all you need really is an internet connection. What's so unique about Earth Engine is you don't actually have to pay for any of these data. So you have hundreds and hundreds of different satellite-based data sets that you're able to access from different satellite agencies across the world completely for free. So with Earth Engine, you're able to actually access and explore all of these data sets using this link at the bottom. This is the Earth Engine dataset catalog, where you're able to kind of see and assess for yourself what kinds of data might be best applicable to your classroom environment or different environmental change analyses that you might be interested in doing on your own. And just kind of highlight a couple of these data sets that are throughout this Earth Engine catalog. We have Landsat 1 through 8 data, which is kind of an iconic data set that you see in a lot of before and after images if you ever look at the news or within Google Earth in and of itself. And that's actually a bit outdated. It should be 1972 all the way up to the present day. We're able to access Landsat imagery all the way back to that first point to really understand in the long term, using time series data, how different populations and ecosystems and Earth's surface itself is changing over time. We're also able to access different satellite climate-based data sets. So things like temperature data that goes back several decades to really analyze how climate change has been impacting different parts of the world differently in terms of temperature shocks and heat waves. We're able to now really start looking at high-res imagery. So getting down to the hyperlocal scale, especially through things like agricultural applications to see how Earth is changing just at the singular plot level or the city level to understand how different populations are adapting. And then we also have several other climate data sets throughout the Earth Engine data catalog. So things like precipitation data and evapotranspiration data. And putting all of those variables together, we're able to get a better understanding in general in terms of how climate change is impacting different parts of the world. And then finally, we have an exhaustive list of other kinds of satellite data sets. So things like terrain data, data in terms of elevation, that you're all, again, able to put together to better understand how our planet is changing in general. So again, the general idea of Earth Engine here is we're able to take these satellite images, apply algorithms to them within that JavaScript interface that I mentioned before, and using that JavaScript interface, we're able to create a series of real-world applications to actually see how we can use those satellite data to help different ecosystems and populations around the world really understand how their planet is changing and what they can do about it. So just to go over two really quick kind of iconic applications of Earth Engine that were among the first applications. The most, I would say, famous application of Earth Engine remains Global Forest Watch. So using hundreds of thousands of Landsat images in particular, a team of researchers out of University of Maryland was able to assess the extent of forest change over time, over the last several decades. And this was the first time this particular global environmental trend was actually quantified at the international scale. So using Global Forest Watch, different policymakers around the world are able to assess how different countries are adapting to climate change and changing their goals in terms of preserving and conserving forests. And so this really creates a sense of accountability in terms of actually measuring and monitoring the extent to which we're actually able to prevent trends like deforestation from continuing to occur. And then the second global application I want to show here is something called Global Fishing Watch. So using Earth Engine data as a base, researchers were able to essentially monitor the location of the world's fishing vessels in real time. And what this actually enables us to do is track things like illegal fishing. So whereas before we really didn't have transparency in terms of where these sorts of illegal fishing vessels were traveling, now we can actually see them from space and track them around the world as these sorts of events occur. And then as a final application here, one of the third kind of most iconic original applications of Earth Engine was a global analysis of surface water change over time. So using Earth Engine, we're able to get down again to the hyperlocal scale, like you can see in this particular hotspot here, and track things like how drought and water extent change is occurring in different hotspots around the world, and extend that again to the global scale to analyze really how different populations are adapting and different governments are changing their policy in accordance with climate change. So how are we actually able to create these different applications? As I mentioned before, this is the JavaScript coding interface that we use with Google Earth Engine. You can see the code in the middle there, where we're actually able to access all of these satellite imagery data sets. And then the map on the bottom, where we're able to see how we can apply those algorithms and visualize them to track these sorts of environmental trends. But there's one pretty big problem here. Unfortunately, not everyone knows how to code. And when we're looking at the next generation in particular, and the high school student and even middle school student age group, again, not everyone is going to have the coding experience to be able to actually go through and process these satellite images. And so that's where the Cloud to Classroom program comes in. So I started Cloud to Classroom several years ago because after working for NASA for several years and kind of tracking these sorts of global environmental trends using Earth Engine, I was also at the same time going to school during the day and going to my biology and earth systems classes and seeing that kids around me really weren't understanding the extent of the global environmental changes that I was tracking every day using Earth Engine at NASA. And I wanted to create a way to kind of bridge that gap, to bring those sorts of satellite imagery data sets beyond just the scientific community and into classrooms like mine, so that other students and teachers would really be able to understand what they're reading in the textbooks and what they're reading in those news headlines that I mentioned before. So Cloud to Classroom was kind of the solution to that. It was a way to actually bring these sorts of Earth Engine data sets to students around the world, help them visualize the data that we're able to use, but without the coding interface in general, as something that was necessary to actually kind of bridge that gap and get access to the satellite data, which we needed to before. So the idea behind Earth Engine is that it uses a Google Earth Engine backend. So essentially using Google Earth Engine, we're able to actually get access to all those satellite data sets. And then what me and a couple researchers are doing is building a series of satellite-based apps to actually present those satellite data sets in a way that's conducive and understandable to even those outside of the scientific community, to actually show these satellite images without students or teachers needing to do any coding whatsoever. And then the final step of the Cloud to Classroom kind of pathway here is actual classroom integration. So now that we've built all of these satellite-based apps, we're interested in kind of learning from you and learning along the way in terms of these sorts of trainings. How do we actually take these satellite-based apps and bring them into classrooms around the world, specifically within biology and earth sciences, but also within the humanities as well, to try and see how we can use satellite data and geospatial data in general from Google Earth Engine to help other students and teachers better understand different aspects of environmental change. So where have we been so far? With Cloud to Classroom, over the last 2 years or so, we've trained about 500 students and teachers, both in person and online. We've developed 18 different online web apps in both long-term environmental change and also short-term hotspots and extreme weather events. We're in the process of developing 10 different supplementary curriculums, which will actually be added to the Cloud to Classroom website later today to kind of supplement all of these different apps and facilitate that last stage of classroom integration. And then we're currently developing seven new web apps entirely based on current events. So things like extreme weather events or hurricanes or earthquakes that are happening kind of in real time that we're able to track using Earth Engine, and then build up apps that we're able to directly give to teachers and students around the world. Really the goal with Clouds to Classroom and with a lot of analyses within Earth Engine right now, just to kind of step back, is to address the United Nations Sustainable Development Goals, which is a set of about 36 goals that the UN and countries around the world have developed to kind of set the pathway in terms of research and development and policy in general over the next decade or so until 2030. So these are goals like we want everyone to have clean water and sanitation, decent work and economic growth. And where we specifically target is the climate action and things like life on land and life below water and sustainable cities and communities goals. So these are the 7 goals that we're targeting in particular with the Clouds to Classroom program. Each one of our different apps on our website is actually tied to one or more of these different goals to kind of set a pathway in terms of where we want our students to be focusing and where we want teachers to ideally be teaching these apps in terms of kind of assessing how we're able to use satellite imagery to address different indicators of all of these goals that we're looking at. So in terms of what apps we've actually created and these topic areas that we're going into, these are our 6 kind of main long-term climatic effects and global environmental change effects apps that we've worked in. So the first is sea surface temperature. We're able to track at the global scale the extent to which temperatures across oceans are changing and how that can impact different coastal communities around the world and their economies. We're able to also track urbanization over time. So identifying hotspot cities around the world and how they've been impacted by these different trends in population growth and city growth over time. We're also able to track drought trends. So looking at things like drought over the last 2 decades and drought all the way up to the present day. So looking at current hotspots of droughts and how it's impacting things like water supply and other factors. Fourth, we're also able to track things like ice melt. So again, looking at both long-term trends and also more short-term hotspots where we're able to see ice melt in a particularly dramatic way. Fifth, we're able to track things like extreme weather events. So these are things like hurricanes and cyclones, things like floods and earthquakes across the world. And not just hotspots here, since this is a long-term trend, we're also able to track the extent to which hurricanes have impacted different communities around the world with varying severities. So which communities would be most vulnerable to these different trends. And then finally, we're able to track human influence in general. So seeing kind of the interaction of multiple human factors, things like agricultural extent and the extent of cities, and how in turn the interaction between all of those different human influences can impact different ecosystems across the world. So just to kind of start going through a couple of these different apps to give some examples, what I decided to do is actually take one of my biology textbooks, quotes directly from that textbook, and kind of show how we can take a single textbook quote and kind of make it come alive with the different satellite-based apps that we're able to create using Google Earth Engine. And this is really what drove the project in general, my kind of just reading these different textbooks throughout high school and trying to see and help other kids visualize using Google Earth Engine the trends that we were seeing just within these kind of dry quotes here. So to start with, one of our earliest apps that we've created, our Drought app, that app was really drawn off of this quote from my biology textbook, talking about how large areas of severe and extreme drought are already impacting every continent just over the course of a single year, and also drawing out some hotspots in coastal countries in Africa, the Cape Town water restrictions in Southwest India. But again, just kind of reading these words, it's very difficult for students and the non-scientific community to really understand where these droughts are actually occurring and kind of visualize in a geospatial sense different hotspots around the world that have been most impacted. So how do we actually translate that to an app? So this is kind of our first demo here, which is a little bit blurry, I apologize. But basically you can see in the map on the right these different colors where we're tracking the extent of drought and drought severity over time. You can see that kind of slider on the left there where we're able to track different years, as well as a time series of the extent of drought from 2000 to 2019. We're also able to zoom in and you can see kind of local hotspots here where we're able to track places like Northern Africa, where we have seen some pretty extreme drought over the last 2 decades and kind of help students to start identifying those hotspots from the local to the global scale. What we're also able to do is get down more locally as well once this video loads. So this is our Drought Hotspot app. So we're able to pick out specific locations, like in this case, Lake Mead in the US near Las Vegas, and see before and after over the course of about 2 decades what happens when cities overuse water and the cumulative effects of irrigation across the Great Plains region. So we created these hotspot apps over 5 different drought hotspots and hotspots of declining water supply across the world, so that students and teachers can really better understand the extent to which drought is not only a global problem, but is also being contextualized in terms of its impact on local communities. What we're then able to do is provide teachers with a set of discussion questions and supplementary curriculum to kind of extend these apps to the classroom and help kind of facilitate a broader conversation in terms of what impacts climate change and global environmental change in general is having on different human populations around the world. So there are really 5 main subject areas that we focus our discussion questions around. The first is the impact of climate change, in particular on the global environmental trends that we're focusing on. So in the case of drought, for example, we're interested in looking at how climate change is impacting different hotspots around the world and why certain populations and ecosystems are impacted more than others as a result of climate change. And I think most importantly here, we're kind of questioning and facilitating these discussions around connections to human populations and local communities. So seeing how these different global environmental changes and climate change is impacting different communities with more severity than others, and how human populations are adapting to those changes. In addition, we're starting to look at environmental justice applications as well. So really looking at why different populations are seeing greater impacts than others when we're looking at particular trends, and what the effectiveness of different policies has been in terms of either kind of promoting those trends or really facilitating their adaptation in a better way in terms of local communities around the world. Fourth, we're interested in actually identifying and asking questions around the identification of hotspots from global applications. So this is more on the ecological side, looking at, when we see things like global drought or sea surface temperature change, where are global ecosystems most being impacted, and what are some adaptations we can have potentially on the more environmental side, outside of the human population side, in terms of helping different animal populations and ecosystems actually recover from these trends. And then fifth, of course, we're interested in asking questions and helping students kind of ask themselves, what are some potential solutions here? So how can we use what we know in terms of environmental policy and new sustainable development strategies to actually help lessen the impact of these different global environmental trends on different communities around the world. So in the case of drought, for example, these are 4 primary discussion questions that we've shaped our curriculum around. The first is, how does climate change affect naturally occurring droughts? So what is it about climate change in particular and the greenhouse effects that's driving increased frequency and intensity of droughts, both globally and also in certain hotspots in your local community and also around the world? We're also interested in looking at how droughts, as intensified by climate change, are impacting water supply across the world. So what impacts does a decreasing water supply have on things like agriculture and irrigation, especially in already water-stressed regions? We're also interested in looking at kind of the human side of different global environmental changes that are contributing to droughts and water supply crises in general. So this is looking at more on the side of irrigation and different agricultural practices that could be impacting water supply crises in different hotspots, particularly in sub-Saharan Africa. And then fourth where are communities actually facing a water supply crisis is kind of another discussion area that we're interested in looking at in terms of identifying those communities and populations across the world that are particularly acutely vulnerable to these different environmental changes that we're seeing. So these are just kind of 4 main topic areas that we've centered a lot of our discussion questions around, just to kind of give you a general idea of what we're looking for students and teachers to be discussing when they're actually applying these apps to their classroom curriculum. So moving on to our next kind of global environmental change area, again, looking at a textbook quote from my biology textbook back when I was actually taking these classes in high school. I remember seeing this particular quote: there have been 1.2 trillion tons of ice melt in the Arctic and Antarctic over the last decade. And you know, just looking at these statistics, it's a very dramatic statistic. But again, it's very hard to visualize spatially in terms of seeing what parts of the Antarctic and Antarctic are actually melting the fastest. And actually kind of tangibly understanding what ice melt looks like in terms of how it's impacting us and how it can actually have an impact across the world, not just in these hotspots in the Arctic. So that gave rise to this hotspot app, where we're able to see kind of before and after. Again, I apologize for the blurriness, the extent of ice melt in this hotspot in Greenland over time. So you can see kind of before on the left and you saw after on the right. So again, we were able to identify 5 different global ice melt hotspots across the Arctic and Antarctic to help students really visualize and understand what ice melt actually means when we're looking at the local scale. Again, looking at a couple of the discussion questions here that we're looking for students and teachers to address depending on needs in terms of bio and earth systems curriculums when we're looking at actually bringing these apps into classrooms. So first, looking at how does sea level rise actually impact human populations? Ice melt is one of the primary factors contributing to sea level rise across the world. So focusing in on sea level rise in particular, how is it actually impacting coastal agriculture and coastal infrastructure developments in acutely impacted communities, which kind of leads us into our second question here: which populations across the world are most impacted by sea level rise at the local scale? So seeing how different communities are adapting and which are being forced to migrate as a result of sea level rise, and I guess by virtue of just the sea level rise crisis in general, ice melt. And then third, how do communities around the world actually rely on glacier melt? So through things like agriculture, a lot of communities in the Himalayas, for example, rely on glacier melt in order to feed agricultural development systems. And so in some cases, glacier melt can actually be good up to a certain extent. So how will melting glaciers actually impact them over the short term and also over the long term as well? And then last, looking again at the ecological side, with less freshwater available, what other ecosystem components might be impacted other than human populations? So looking at things like mangrove ecosystems or other coastal forests across the world, how will these different ecosystems actually feel the impacts of such a human-driven crisis that we've created? Moving on to our third example quote and app pipeline here. Here we're seeing this particular quote from the textbook, looking at the most urbanized regions of the world. So here we kind of see different percentages of populations in different continents that are being most impacted by urbanization and population change. But again, just using these statistics, it's quite difficult to actually visualize and contextualize what that actually means geospatially, and helping students understand what these different hotspots are when we're looking at the extent of urbanization across the world. So looking at how this actually translates to an app, here we can see an Urbanization Explorer app, where you can see my mouse on the top kind of going between these years. This is the year of 2000. This is in Shanghai. And then moving forward to 2007, you can see the growth of the city. And then moving all the way forward to 2012, you can see this pretty dramatic urban growth over time. What we're also able to do is click on different hotspots on the app and actually track how the extent of nightlights data is increasing over time, and then export that data to charts and download the data as well for students to start exploring on their own to kind of actually start quantifying the extent of these global environmental trends in these different hotspots and also in their local communities. So looking here at our discussion questions, we're again addressing a lot of human impacts and also ecological impacts here. So we're looking a little bit more advanced on the science side here, but looking at with higher daytime temperatures, reduced nighttime cooling, and higher air pollution levels, how could things like the heat island effect be potentially dangerous to different populations across the world and in these really urbanized areas like we looked at in the app? So how do all of these different ecological and human-caused factors interact to create these different scientific impacts? Second, since the heat island effect is impacting surface temperatures across the world, how can we kind of extend these trends to looking at things like a city's electricity usage over the summer? So things like infrastructure and how different infrastructural trends and policies can potentially adapt or in turn cause these different global environmental changes like urbanization. We're also interested in looking at kind of the ecological side of this as well. So how can communities that are being extremely urbanized rely on nearby freshwater bodies like the lakes that I showed you earlier before without causing those sorts of extreme environmental disturbances and lack of fresh water as cities kind of expands? And then looking kind of on the more local scale, what does your community in particular utilize in terms of your local water sources, and how can urbanization actually impact the degree to which we're able to continue using those water sources in the near and more distant future? And then finally, looking at the solution side, what can potentially be done to alleviate the dangers of intense heat and sunshine and the heat island effects in cities in particular, as well as low air quality levels. So kind of bringing all of these different ecological and human-based factors together to assess how these different environmental trends are impacting communities across the world. For our next example of global environmental change and our different apps, here we see this quote here in terms of looking at extreme weather and climate events and how the impacts of these different events in recent decades are related to human activities and in turn how they actually impact humans in particular. So starting to actually visualize this trend here, we have this Hurricane Explorer app where all of these different lines that you're seeing on the screen here are hurricane paths, in this case in 2017. And we're able to go back all the way to, I believe, 1930 here to see hurricane tracks on a yearly basis. We're kind of scrolling through time here, and as you can see on the left, to see how the intensity and the frequency of these hurricanes are actually changing around the Caribbean region in the US over time. And you can see in that chart on the left, I just clicked on a particular point on the map, we're able to see how that frequency of hurricanes at that particular point has changed all the way from 1900 to the present day, and how in turn we can see the category changes, so hurricane intensity all the way up to the present as well. So tracking things like long-term trends in these extreme weather events and how they're impacting different local communities and your community in particular. What we're also able to do here, though, is get down to the local scale and look at a local hotspot app in terms of hurricane disturbance. So here you can see kind of before and after forest damage in the Everglades in Southwest Florida. So you can see the impacts of Hurricane Irma throughout this key of mangroves here. And so this is looking kind of more at the ecosystem side in terms of how not only populations, but also ecosystems are impacted. So now we're going all the way over to Japan to see kind of the human impacts here. You can really take a look at the lights of the city kind of before and after, where before is on the left. So as I kind of scroll through, you can see now after the city's a lot darker, you can see the light and the dark again. So this is really helping students actually tangibly understand what impacts these sorts of hurricanes and extreme weather events have on infrastructure in cities. And then again, kind of more on the forest side as well in terms of how nature and how different ecosystems and animal populations are impacted by these different human-caused trends, like increased intensity and frequency of these extreme weather events. Moving on to the discussion questions here, we're interested in helping students understand how climate change exacerbates flooding. So most students and teachers are able to really see in the news an increase in these sorts of news stories about floods or extreme weather events due to hurricanes. So students really need to understand critically how climate change is actually directly impacting flooding trends and increased frequency and intensity of these sorts of extreme weather events. And then in turn, again, how will stronger storms actually impact human populations in terms of infrastructural developments, the poverty and economic development of different cities across the world, and why different cities have had kind of more impact on the scale of these stronger storms than others. Third, how will climate change enhanced droughts actually impact wildfires, which is a whole other area of these direct climate change impacts that I haven't gone into yet. So looking at things like drought and decreased water supply, how is that actually impacting these very human-driven events like wildfires? And then finally, how will climate change enhanced droughts actually impact water supply in different communities? Here we're looking at drought in the context of kind of an extreme event in the current day. So not looking necessarily at these long-term trends, but looking at more current droughts across the world and how those are currently impacting water supply rather than what we looked at before, which was more in the long term. Moving on to our next app here, we can see this kind of very general quote: global sea surface temperatures are expected to rise by up to 4 degrees Celsius by 2100. Again, very hard to contextualize when we're looking at, how different hotspots and global oceans around the world are expected to be impacted by climate change over the next several decades. But using this app, again, we're able to actually kind of look at this more globally. And you can see, based on kind of the brightness of the blue here, the extent to which sea surface temperature has changed over time. So this is just the still image here. But using this app, again, we're able to go all the way back to around the year 2000. So looking at the last 2 decades or so in terms of yearly sea surface temperatures, as well as click on points to see how different particular spots throughout world oceans are being impacted by sea surface temperature change over time. Looking again at the discussion questions for this particular app, we're interested in facilitating discussions in terms of how increases in sea surface temperature are impacting storm intensities, and how does climate change then directly impact the intensity and frequency of storms as a result of sea surface temperature change directly. We're also interested in looking at things like what are the impacts of ocean acidification and ocean warming on different animal populations, so marine life and coastal species. So again, looking at kind of beyond the human side, but looking at more of the ecological side in terms of how these sorts of climatic trends in terms of sea surface temperature change are impacting different aspects of different coastal and marine ecosystems. And then further extending these different impacts on marine life to human populations, how does the welfare of these different marine ecosystems actually impact human populations? So this is looking at things like coastal economies and how a decrease in particular kinds of fish, for example, could impact the fishing industry in places where fishing is really dependent upon as the primary source of economic development over time. So how can seemingly unrelated climatic trends like sea surface temperature increase actually have a tangible economic and livelihood impact on these different coastal communities across the world? And kind of extending this in particular, what groups of people are currently facing the greatest threats from increasing sea surface temperature change, both in terms of sea level rise and also in terms of those sorts of economic impacts as well. So moving on from our sorts of long-term climatic impacts, what we're also able to look at is kind of getting more down to the current scale. So looking at some more recent extreme climatic impacts, such as Australian fires, the fires throughout the Amazon over the last several summers, and also the iconic Brazilian floods of a couple years ago. Now, these are just kind of our 3 starting points for these particular sets of apps in terms of the current events, but I'll talk a little bit later in terms of how we plan on expanding this, because this is our kind of most pressing priority at the moment with the Clouds of Classroom program. So looking at our first app here, this is looking at Amazon fires. You can see in the blue the extent of deforestation over the last 2 decades, and in the red and orange is the extent of forest fires. And what this app really helps you show, you can see when I'm zooming in here, is how deforestation extent overlaps directly with the extent of fires. So what this app is really showing is is helping students draw direct connections between human impacts like deforestation and these sorts of ecological responses like forest fires. So how are humans directly driving these trends on the local scale? And how are these trends being exacerbated like global scale factors like climate change and resultant drought? Moving on to our next app here, we're able to look at fires throughout Australia and how they're impacted by drought. So here you can see the extent of drought. You're seeing this particular drought scale from 2000 to 2019 and how that kind of red area grows as the intensity of drought grows. And then again, we're able to also look at fire extents as well. So now you're seeing fires from 2019 to 2020, 2015 to 2016. And as I kind of check off these additional boxes, you're able to see how the extent of fires has changed over the course of the last 2 decades or so. And then further, how that will impact these sorts of local communities across the Australian coast and around the capital in particular. So again, going from that national scale to the more hyper-local scale to assess how different communities across Australia and across the world are really adapting. So moving on from these sorts of current events, I want to talk just a little bit about what we're planning to do moving forward with the Clouds of Classroom program in terms of future plans. So moving forward, as I mentioned, our most pressing priority at the moment is really expansion of our real-time climatic events applications. So how can we better track things like forest fires, things like hurricanes, which are coming with increased frequency, and also things like droughts, which are currently impacting communities really across sub-Saharan Africa and across the world. And so I think really the primary reason why we're interested in looking at these sorts of real-time climatic events is, again, we want to go beyond the headlines and help students, once they actually read the news and start seeing these trends when they open up their social media or their news headlines every morning, help them actually visualize and better understand how these different headlines are sort of coming to life and tangibly already impacting communities across the world. And furthermore, what they might be able to actually do to help. What we're also interested in doing is increasingly integrating other Google Earth outreach tools. So the 2 images you're seeing here are from a tool called Google Earth Voyager, which I link at the bottom here. And really the goal of Voyager is sort of to be the front page of Google Earth. It's where you're able to see dozens and dozens of different curated geospatial stories like Indigenous lands in Brazil or the Canadian Arctic, which are 2 example stories here that the Google Earth outreach team has put together to help different students and the public across the world better understand these sorts of global environmental trends and how in particular those are impacting different human populations like Indigenous communities across South America. So what we're really interested in doing is trying to link a lot of these Voyager stories and other Google Earth outreach-based tools within the Earth environment to these different environmental change apps through Clouds of Classroom to create kind of a fuller experience for students and teachers to help better integrate these apps into classroom curriculum depending on needs. What we're also interested in doing is starting a field data collection integration with apps that users themselves or teachers themselves could potentially start generating. So here we'll be working with 2 primary softwares for field data collection. The first is Open Data Kit, which is typically integrated with a lot of Google tools. And the second is taking advantage of some existing NASA tools through the NASA Globe Citizen Science Program. So what we're interested in doing is helping students and teachers actually start collecting some of these kinds of environmental data sets on their own. So tracking things like temperature change and precipitation change, and also things like forest change and land use change in their local communities. And then actually learning how to integrate those sorts of data sets into both existing apps that we'll be building and also learning how to actually build those Earth Engine apps using coding themselves and integrate their own data as well. So this is a bit of a more distant goal, but definitely something that we're looking to work towards in terms of making these apps even more engaging for students and teachers. And then finally, we're always very interested in knowing your preferences and needs in terms of these apps. really the goal of Clouds at Classroom is to cater to teachers and to cater to you. And so really what we're interested in doing is hearing from you in terms of, what's working and what isn't in terms of integrating these apps into your classroom curriculum, and whether the current topics that we're addressing in terms of extreme weather events and these current events are preferable, or whether you would really prefer more of the long-term impacts. This project should really be driven by all of your preferences and needs. So I really encourage you to reach out to us, and I'll include kind of links and resources in an email chain that will be sent out following this particular training. And the last thing that I'll really address here is how we could potentially involve you in potentially sharing your ideas in terms of how to bring Clouds at Classroom to students with a broader Google Earth Outreach community. So if you're interested in bringing Clouds at Classroom to your students, or if you have a cool idea in terms of how you can potentially link these sorts of apps or these global environmental changes to your biology or Earth systems curriculum, then you could potentially have an opportunity to actually give a short lightning talk to other teachers around the world and to the Google Earth Outreach team over the next several months or so. So again, following this training here, we'll send out the links and a Google survey that helps you actually work through some of these ideas and submit the ideas to us to see whether you might be eligible to actually present this idea with the Earth Outreach community in particular, to facilitate actually sharing different applications of how Clouds at Classroom can actually work in different classroom settings. And with that, I'm really grateful for your time, and I would love to turn it over to questions, depending on everyone's interests. So thank you very much. And here's the Clouds at Classroom website at the bottom.
Again, if you have any questions, feel free to enter them in the box at the bottom. There are a couple questions already. So I have to say, there were many more comments on how awesome you are, Liza, than there are questions. But we'll jump into the questions that are here. First one is, I teach about the Salish Sea. Is there a way to get data on specific regions?
Yes, so that's a great question. Anytime you're interested in getting data, or you're interested in seeing an app in a particular geographic location, we just ask that you send us a note. We're going to send out links to our different email addresses that you can potentially reach out to in terms of requesting different apps and different hotspots. But if you're interested in starting to tackle those data sets in that particular region yourself, I really encourage you to just kind of jump into the Google Earth Engine platform just on your own or with your students. There are a lot of really extensive developers resources, developers guides, and sample codes within the Earth Engine environment, almost to the point where you don't really even have to write code on your own. You can just use sample code in a lot of cases. So definitely check out Google Earth Engine on your own if you're interested in kind of starting to tackle these trends.
Cool. Next question, are there ways to link in external data sets like environmental hazards data, for example?
Yes, that's another great question. So within the Google Earth Engine platform, you can absolutely upload several forms of your own data sets. If you have point-based data, you're able to upload that kind of more geographic data in terms of shape files. You're also able to bring that into the Google Earth Engine environment. And if you also have more raster or image-based files, you're able to upload that to the Earth Engine platform as well. So while we don't have the functionality within kind of the forward-facing interface of the apps that we've already developed to integrate your external data sets, if you're interested, again, just try and jump into the Earth Engine environment, and I'll definitely send out links after this as well in terms of how you can best do that.
Cool. Is there a way to connect having students create Google Voyage and Google Earth with the data available in Cloud at Classroom?
Yes, so there are definitely a lot of ways that you can integrate the two. Currently on the Clouds at Classroom website, on each individual app page, actually at the bottom, we have examples of several different Google Earth Voyager stories that are related topically to the different global environmental change trends that we're tackling. So you can already see we're developing those sorts of integrations with Voyager stories in particular in terms of looking at how they could potentially link to these different Earth Engine apps. But I definitely recommend just kind of exploring through Voyager as you go through these different Clouds of Classroom apps and seeing kind of beyond what we already list, how students can kind of find those forms of storytelling potentially more engaging.
Great. Are you partnering with instructing experts to wrap some pedagogic best practices around these apps?
Yeah, that's a great question. So we have not yet, but we are definitely starting to form a group of teacher experts who will be working with us to actually better develop the curriculum around teacher needs and directly link them to curriculums and especially within the US, things like AP standards or national standards in terms of how these different geospatial technologies can actually link to things like biology curriculum standards and earth sciences standards in particular. But that being said, if you're interested in working with us in really any capacity, we're always looking to collaborate with teachers who are interested in helping us develop these different curriculums. None of the people on the team actually developing the apps or a lot of the curriculums are teachers ourselves. A lot of us are students and a lot of us are scientists. So the teacher input aspect is definitely something that we're interested in looking at and really why we decided to host this training in general.
Have you considered expanding the program to other audiences outside of the classroom?
Yeah, so that's another great question. So we're definitely interested in going beyond the classroom. And actually, we're talking to several different news agencies right now to see if we can directly integrate these different apps into news stories. So when things like extreme weather events like hurricanes or floods or earthquakes occur, we want to directly be able to quickly generate one of these apps and then integrate the app into a news story to help the broader public better understand these trends and again, kind of contextualize it on the more local scale beyond just the headlines and the statistics.
All of the apps that you demonstrated were around environmental change and climate change. Can the apps be applied towards humanities classes as well? Maybe something outside of the sciences?
Yeah, so they certainly can be applied outside of the sciences and outside of computer science in general. All of these different apps that we looked at are really just about assessing the world on kind of through a geospatial lens. So when we're looking at things like history, for example, it's pretty easy for us to also look at the world through time and see how things like urbanization has impacted different populations and look at that through a world history class, for example, or some kind of social science class. All of these different trends that we're looking at are not just impacting different ecosystems and different animal populations. They're really just human driven. And I think I covered that through a lot of the discussion questions. We're definitely not just interested in keeping things kind of on the natural side. We really want to help students better understand how humans are impacted at the core of these climatic trends. So these apps can absolutely be applied beyond just the sciences and into more humanities-based classes where we're looking at human impacts in particular.
Cool. Do you envision a platform for sharing or modifying course materials from instructors using the Cloud Classroom?
Yeah, that's a great question, and we've definitely started to consider that as well. I think what we're interested in doing is forming some form of a Google group to start facilitating these kind of more natural interactions between different educators and users of Clouds of Classroom around the world, so that teachers can start exchanging their own lesson plans and examples for how they're applying Clouds of Classroom in their own classroom environments and in their own bio and humanities curriculums. So I think hopefully we'll be sending out that link to that Google group within the next couple of days or so. But that's going to be our, I think, main form of communication between different educators across the world for exchanging their information over the next couple of months.
There's a personal question here. What are your future plans post-Stanford?
That is a great question that I wish I knew the answer to. I think after I finish my undergrad, I think I will definitely go to grad school. I really love this field of using satellite imagery to monitor different aspects of global environmental change. And I'm working in particular on food security problems globally, so looking a little bit further away from the ecosystem side towards the humanitarian side. So how can we apply a lot of the different satellite imagery trends and algorithms that we're able to use to track forests to track humans now? So looking at kind of all sides of global environmental change. And so I think that will be kind of a new focus area that I'm looking at moving forward. Ultimately, after I finish grad school, I don't know whether I want to ultimately go into industry or academia or the government sector. Really, all I know is I love this field and I want to keep studying in whatever capacity I can.
Stanford's definitely a great place to explore some of that.
Yes, definitely.
So one more, we have a participant from Kazakhstan asking if they can become an Earth Engine teacher in their country. They've been working in the platform for 2 years. Any advice for someone wanting to get into the process of teaching Earth Engine?
Yeah, so that's a great question. So if you're interested in teaching Google Earth Engine in particular, I definitely encourage you to check out the Earth Engine developers page. They have a lot of sample curriculums that you're able to look at, developed by other professors and educators around the world who are more interested in teaching on the coding side. And using the developers page, you can kind of work using that as a basis in order to start bringing that into your own classrooms and integrating both Clouds of Classroom with that kind of back-end aspect of Google Earth Engine as well.
Awesome. I think we're about out of questions. That was a great presentation, and thank you very much, Liza. It was awesome. As always, everything you do seems to be awesome.
Thank you very much, everyone, for attending.